There are all kinds of natural cycles that affect the weather, but most of the time, those cycles only get attention when they have a hand in severe weather. According to Dr. Keith Blackwell of the University of South Alabama, the increase in tropical weather is the result of a natural cycle called the Thermohaline Circulation. The Thermohaline Circulation is a natural conveyor belt of ocean water that winds around the continents. The circulation runs in a 60-year cycle and can cause prolonged periods of warmer than average sea surface temperatures in the Atlantic, warm water on which hurricanes thrive.
Because the majority of the North Atlantic warms up, including the Gulf of Mexico and Caribbean, and stays that way for, 2-3 decades, it helps to change the atmospheric environment over the Atlantic as well, making conditions more favorable for hurricanes. It's not just the warm water that does it. It is the fact that the warm water provides feedback processes on the atmosphere, which then alter the steering currents, alter the upper level atmospheric environment that allows for more hurricane activity and more intense hurricane activity.
That feedback leads to light winds and a lack of significant weather systems to interfere with the growth of a tropical cyclone. Warm water and a light wind from the surface of the ocean up through 30,000 feet in the atmosphere is crucial for hurricane development. And it was that kind of environment that developed over the Gulf of Mexico this last year for Dennis, Emily, Rita, Wilma, and the big one, Katrina.
If a hurricane had to choose an environment to move into, to strengthen, this was the environment. Katrina had an incredible atmospheric environment ahead of it in the Gulf. As it moved off the loop current, it also entered a little less ideal condition in the atmosphere, began to weaken as it moved up toward the northern Gulf Coast. Still a very powerful storm, but more importantly, it became larger in size, which meant that its influence on the ocean became larger as well. And the storm, the size of the storm, the great size of the storm, as well as the exact path it took, where it actually was forcing water, trapping water up in the concave area of coastline along the Mississippi, Louisiana coast, there where they intersect, those two coastal areas intersect. Water is easily trapped in that region. That helped generate an astounding surge, an astounding storm surge, which just wiped the coastal Mississippi area off the map. What is the one thing that does absolute severe damage when a storm makes landfall? It's the storm surge. The storm surge is like a tsunami sweeping on shore in some ways, because if you think about it, the level of the ocean comes up, well, in Katrina's case, comes up 25, 30 feet, and it's moving, that storm surge is moving into a bay that's not 25, that it doesn't have water level at 25 to 30 feet. Think of the elevation difference between an ocean rising tremendously and water or land at much lower elevations along the coastline. Think of the force, think of the speed at which that water and the severity at which that water is going to be surging inland. It's going to tear everything out. It's just going to tear everything to pieces as it moves inland.
After Katrina, Dr. Blackwell testified before a Senate committee looking to improve hurricane forecasting. He believes wholesale changes are needed in the way we predict hurricanes. Blackwell says we should base the strength of a storm on more than just the wind speed alone. Hurricane Katrina's official rating at landfall was Category 3, but Dr. Blackwell says that's simply absurd.
So, what kind of number does a Category 3, if a person experiences a Category 3 hurricane, and yet their house got wiped out by a 30-foot storm surge, they're going to say, well, what's a Category 5 going to do to me,
Right.
Or if a Category 3 could put in a 30-foot storm surge, would a Category 1 bring in a 10-foot storm surge? So there's a real disconnect between the Saffir-Simpson scale, the number assigned by the Saffir-Simpson scale, and really the true effect of the hurricane at landfall. On a scale of 1 to 5, it was a 5, as far as storm surge goes. Wind, probably a good, strong Category 3, when it made landfall. And that held together really well after it moved inland. And so it brought those Category 3 winds and Category 2 winds inland a good long ways, and therefore it caused a lot of destruction inland across the Mississippi. Rainfall, 1 to 2, category 1 to 2 as far as rainfall goes. Wasn't exceptionally heavy. One of the reasons was because it kept moving at a pretty good clip along, and so didn't drop, 20, 30 inches of rain on a place like some storms have. As far as size goes, good 4.
There are lots of lessons to be learned from a year like 2005. Lessons like changing the way we measure hurricane intensity and even changing the methods of forecasting for 3 or 5 day periods. One thing that is sure in Dr. Blackwell's mind, the 2006 season may be just as intense as '05 was.
I think more than the total number of storms that we have next year, the thing that really needs to be focused on is where are the storms going to recurve out of the tropics and into the mid-latitudes? Are they going to recurve out in the Atlantic off the East Coast and not bother many people except people in Bermuda or something like that? Or are they going to recurve up the East Coast? Or are they going to recurve further west into the Gulf of Mexico like they did this year? We don't know.
Here across the northern half of the state, we have to be concerned about every hurricane season. Even though we are not on the immediate coastline, we have great impacts when tropical systems move into the central Gulf Coast well inland. For example, last year during Hurricanes Katrina and Dennis, thousands of trees were blown down. Many people had no power for days. With landfalling hurricanes in the Gulf Coast as far north as Birmingham, Tuscaloosa, Anniston, Gadsden, we can deal with flooding rains, damaging winds around the core of the hurricane, and the spin-off tornadoes that can be a major problem. So what about the year 2006? Almost every tropical expert, including Dr. Keith Blackwell of the University of South Alabama, Dr. William Gray of Colorado State University, they all believe that 2006 will be very active again. All of the ingredients are in place. Of course, the question is, as Dr. Blackwell pointed out, we don't know where they will recurve. Will they stay in the open waters of the Atlantic? If that's the case, it's no story. Will they recurve up the East Coast, or will they impact the central Gulf Coast again? There's some school of thought that this might be the year for the East Coast to be threatened more. Statistically speaking, places like Miami, Jacksonville, Cape Fear, Cape Hatteras, Long Island and Boston are all statistically overdue. Could this be the year for the East Coast hurricane with a quiet season for the Gulf? The answer is simply we don't know. We'll have to wait until the season begins and see how things line up. The hurricane season begins on the first day of June. It wraps up the last day of November. But typically, in an average year, the big months are August, September, and early October. That's when the tropical waters are at their peak in terms of the warmth. And that's when conditions can be favorable for deadly hurricanes. And you can bet, come June, we'll be watching the tropics very, very carefully.